Hi, good morning everyone. This video builds upon my last video. My last video was this blinking LED. I'll point one thing out. In this delay routine, I was calling it and then returning it. Well, particularly this return, MPLab didn't seem to like that so much. When I clean and builded the code, it accepted it, but it was showing up as one of those minor errors. So because it kept drawing my attention, I didn't want to look at that anymore. So I replaced the call with GOTO, and I got rid of the return. And I just went GOTO and I gave it a label back to where it should be returning to. Anyway, this code here is to basically take 5 push button presses, and when you push the push button 5 times, an LED lights up. So there's no blinking of LEDs, and therefore a delay routine is really not necessary for the on and off switching of an LED. But I did actually use the delay subroutine to debounce the push button. I experimented with using a capacitor across the switch to debounce the switch, and I had mixed success. So what I tried to do is just use a delay routine after the push button is pressed before I decremented a counter. So I'll go through this code. I'll try to skip over what's not necessary. I won't discuss the delay routine. See the last video for that. These first equates for inner and outer loops, they pertain to the delay routine, so I won't really explain them. I created another counter called R3, and I gave it a file register location. I just gave it the next file location, and I have it counting up to 5. I initialize the GPIO pins on the chip, setting GP0 as an output and the rest inputs. In fact, I guess I forgot to mention, in this case I wanted the mClear pin on because I wanted to reset the chip. I wanted the ability to do that, and so I put it as on, and then GP3 is as an input anyway, so GP3 is the mClear button. So then the tri-state register I set up the way I've configured it here. Just to start things out, I wanted to clear the output pin, which is GP0, and then I moved a literal value into the working register so that I could put that value through the working register into the file, which I called R3. So I created a file called R3. I just gave it a name, and then I load up that file with a value of 5 in hex, although it would be the same in decimal as well. Then the code is the main code. I called it main. BTFSS GPIO, and it will be testing the state of GPIO pin GP1. BTFSS GPIO pin GP1, and then skip the next line of code if it is set. The next line of code just sends it right back to the first line of code. So it's just sitting here constantly checking to see if GP1, which is an input pin, is getting a high. When it receives a high, it's going to skip if set. So it'll skip this next line of code and it will go to the delay. And the delay really is only for the purpose of debouncing the switch. And without going into long explanation, I arrived at this value, 0x9c, as a good value to debounce the switch with for the inner and outer loop. And it was a bit testy, definitely testy. I had a lot of problems debouncing the switch even still. It's still not perfect, but it's good enough. So anyway, when there is a high detected on GP1, it skips this line, goes to the delay routine, and then it is instructed to go to decrement, and it'll decf, skip if 0, decrement file, the file being R3, the whole byte of information, not just a bit. And each time a high is detected on the push button, it'll decrement R3. Now we already loaded up R3 with a counter with 5 in it, so it will allow 5 button presses. If there's still a counter value in here, it'll send it back to main, waiting for the next button press. But once 5 button presses are pressed, it will skip if 0 when R3 counter becomes 0. So it'll skip this next line if R3 is 0, and it'll go to bit set F GPIO GP0. This is the output pin. We already cleared the output pin, so it's not lit up. So when the counter reaches 0, called R3, which represents push button presses, and it reaches 0, then it will light up LED output pin GP0. So that's it. And when I go to my development board, you'll see me pushing the button 5 times and an LED lighting up.
Okay, so I have the M-Clear pin enabled on GP3. I'll push it again. Here is GP1. Here is GP0. This yellow line here is the output pin. This line here, going into the chip, is GP1. It's the input pin. The input pin is hooked up to a push button. It's a shame, but I didn't debounce this switch way back, so I have to include a delay routine in the code. I have to be delicate and quick with my button presses, or I still get some bounce. Anyway, here we go. 1, 2, 3, 4, and 5. And you can see number 5, button press, it lights up the LED. And mClear should reset everything. One more time. 1, 2, 3, 4, 5. If I get really sloppy with the button presses, it doesn't really work. 2 button presses. I just 2 hard presses. It just goes on right away. So maybe some modified duty cycle of a 555 timer with a short on pulse might really trigger this nicely. But it works well enough. Let's get the light off. Okay, thanks for watching.
Alright, I wanted to tag this last video in here just to show some problems I experienced. So this is the data sheet for the PIC10F200, and on page 109, oh, hold on. This is the 18F MCU family reference manual. Well, that would explain a few things. So, this is the PIC10F200 manual, and it shows a more limited set of instructions. This is the 18F manual, and it has codes or instructions, opcodes, excuse me, like TST-FSZ, test F, skip if 0, and then there's compare file with WREG, skip if it's equal to, CPF-SEQ. To me, these are some interesting ways to test or compare the bits contained in a file register location. So there's a few different ways to do things, but once again, the instructions in the 10F200 are much more limited. I'll even try typing in CPF-SEQ. So here I am here. Just try CPF-SEQ. No recognition of it. Or TST-FSZ. TST-FSZ doesn't work either. I'm just showing that for my own sake, so I remember it. Not necessarily trying to teach people things they may already know. Thanks for watching.